The marks of 450 candidates in an examination are normally distributed with a mean of 40 marks and a standard deviation of 15 marks. Given that the pass mark is 36 and 5% of the candidates obtain a distinction by scoring X marks or more, determine the Roman 1 number of candidates who passed, then Roman 2 value of X. So solution. So we are being told that there are 450 candidates, and the marks are normally distributed with a mean of 40. Mean equals to 40 marks, and it has also a standard deviation of 15 marks. Now, if it's the normally distributed, then we can sketch this. We can put the information in a sketch like that. So they are saying that it has a mean of 40. That is 40 marks, and the pass mark is that 6 marks. So that 6 marks, that is the pass mark, and then 5% of the candidates obtain a distinction. So we can have that. This is X. So this is 5%. Now they want us to find the number of candidates who passed the exam. Remember that I would say that this 36 is the pass mark. So the candidates who passed the exam is this shaded area. So all these candidates passed the exam. Now we are going to convert this this normal distribution into standard normal distribution by using this formula. Z equals to X minus mean over standard deviation. Now this equals to X here is 36, so we have 36 minus mean is 40 all over standard deviation, which is 15. So this equals to -4 all over 15, which equals to, we have 4 divided by 15. This equals to negative 0.26. Negative 0.2, we can make it 7. Therefore, we can now write this this normal distribution in a standard normal distribution curve, which would be this one. Now with the normal distribution, standard normal distribution curve, mean is 0, and then now we have changed that 6 into now negative 0.27. Negative 0.27. Now once we change like this, we shall now be able to read from the tables this value. negative 0.27. And remember, so this negative, remember the normal distribution curve is symmetrical above the mean, meaning the area on the left of the mean is equal to the area on the right of the mean. Therefore, we are saying that the set value equals to here, it is 0.20 plus 0.07. Remember, it's negative, meaning it's on this side. Now we want to check from the table 0.2 and then plus 0.07 to get this area. Now this is the area under the standard normal curve. Now need to check 0.2. 0.2 is this one. Then on this side, two decimal places, we have 0.07. Check 0.07 is this one. So where the two meets, so they meet here. They are meeting here. 0.10642. So we shall write this one. Area will be equal to, where the two meets, this one, 0.10642. So once we get now the area from here up to this point, remember the area under the curve is equal to 100% or is equal to 1, and the normal distribution curve or the standard normal distribution curve is symmetrical about the mean, meaning the area from mean to this side is 0.5 and the area from this mean to this side is also 0.5. So to get the total area that represents students who passed the exam, total area, we now take this 0.10642 plus now this area from the mean to this side, which is 0.5. So let us add plus 0.5 we have 0.5 plus 0.10642. So this equals to 0.6064. So this will be the area which is the same as 60.64%. So now this represents the total number of students who passed exam, but there were 450 candidates. So the questions wants us to find the number of candidates who passed exam. So the number of candidates who passed exam is represented by 60.64%. Therefore, the number of candidates who passed exam will be now 60.64 per 100 times now the total number of students or candidates is equals to, we now take this 60.64 divided by 100 times 450. So approximately this equals to 273 candidates who passed exam. 273 candidates passed exam. Then they say that 5% of the candidates obtain a distinction by scoring X marks or more. Determine the value of X. Now we have already drawn this the standard normal distribution curve. The mean is 0, and they are saying that now this is 5%, those who are scoring distinction and above, so we can say that this is X. So 0.5 is 0.05. Now this area is represented by 0.05. Now we can get this area because we know that from this up to starting from the mean on this side is 0.5. So if from here up to here is 0.05, then we can get this area by subtracting. So we take 0.5 minus 0.05. So this area is 0.45. So we can now use the tables to find the set value that stands for 0.45. And remember, 0.45, this equals to, okay, now this is the area. So we shall come under our standard normal curve and try to locate this area. So we come inside to try to locate 0.45, 0.45, 0.45. Okay, this is 0.450, so this is greater than what we are looking for. So we can take this one which is close. This is the 0.449, which is close to 0.45. So once we identify this area, then we check on the left hand side. On this side we have 1.6. We have 1.6. And then on the upper side we have 0.04. So plus 0.04. Remember, we shall be getting Z value. So this equals to 1.64. So that is the set value that will give us area of 0.45. Now once we get the set value, we go back and apply the formula, this formula, that Z is given by X minus mean over standard deviation. Now that we have the set value, which is this one, we now need to get the value of this X, which is this. Therefore, we shall say Z value, which is 1.64, equals to X minus, now we have the mean, which is 40, then over the standard deviation, which is 15. So we can make it the subject here. We multiply both sides by 15. So we have 1.64 times 15 plus 40 equals to 2x. Let's see, 1.64 times 15 plus 40. So this will be 64.6. 64.6 marks. So x will be 64.6 marks, meaning that from this equation, that 5% of the candidates obtain a distinction by scoring x marks or more. Determine the value of x. So those students who are getting distinction, they were getting 64.6 marks and above. Thank you for watching and listening.